Hello, and thank you once again for joining this Wowza webinar on WebRTC in-depth technical discussion. We will be starting in about 2 minutes, but if you could please, I'm going to post a poll here, and if you could enter your information in the poll, we definitely appreciate it. Hi, everybody, and thank you once again for joining us for another Wowza webinar. This one is on WebRTC in-depth technical discussion. We'll be starting in about 50 seconds here, but if you could, please feel free to enter your information into the poll here. We always like to know how people are currently streaming, your current latency you're getting, if you are currently using our services, as well as what industry you're in. All right, everybody, and welcome once again to a Wowza webinar. This is, again, WebRTC, the in-depth technical discussion. And we are about to get started. There is a poll in progress. Please feel free to type your answer into that poll. We definitely appreciate it. The Q&A window is where we will be answering questions back and forth. The chat window has been disabled, so please, if you do have questions, type them into the Q&A window. And now, Anne.
All right, let's get started. So hey everyone, my name is Anne Balistreri. I'll be your moderator today. I work in product marketing at Wowza, and I'm excited to be hosting this session. So WebRTC is a functionality that we've been working on continuously here at Wowza. We've made a lot of awesome enhancements that we'll be going over too. I do have a couple of housekeeping items. Justin went over a couple of them. But today's webinar will be available on demand after the live season. So we'll be emailing all the attendees with the recording, so keep an eye out for that email. Next, we'd love to hear from you during today's presentation. If you have a question for our speakers, please send it through the Q&A window, and we'll be answering questions throughout the session. So next up, we're gonna go over the agenda for today, and there's a lot we'll be covering. So we're going to start with brief overview and intros, lead into browser compatibility. We'll talk about configuring your WebRTC application. Oh, here's our polling results. I'm going to close that out for now. But thank you for taking that. Then we'll be leading into setting up the broadcast and playback page, recommendations to tune your workflow, using WebRTC for real-time delivery, scaling WebRTC, publishing and viewer access control, and last but not least, the roadmap. So it's a ton of content we're going to get through. We're going to try to get it done in 45 minutes of presentation, may go a little bit over, and Q&A throughout. And again, for questions, please place them in the Q&A window. Moving on to panelists. So if you've been attending our webinars recently, you'll recognize these faces. First off, we have Barry Owen, the VP of Solutions Engineering, and Anthony Lazaro, Senior Director of Product. We also have Frank Durant with us today. He is the engineer for Wowza Streaming Engine and knows WebRTC inside and out. So we're very lucky to have him. Thanks for everyone being here today.
Absolutely.
All right, so let's do a quick overview. WebRTC is a open source protocol that enables real-time communication between browsers. It's super fast and browser based. It does have some limitations. It's not designed for every use case. It is designed for small group video conferencing and doesn't scale well on its own. So a question that we sometimes get, and one that actually came up in the signups, was what value addition do we get if WebRTC is free? So while that's a very good question, pairing WebRTC with Wowza enhances WebRTC's capabilities and it improves scaling, transcoding, restreaming, simple publishing, and authenticating publishers and viewers. So a lot of these things we'll be going over today. We're going to kick it off with going over the supported Wowza and WebRTC use cases. So Anthony, I think I'm going to hand this one over to you to start talking through.
Great. We have a ton of different use cases that we can support as it relates to WebRTC. Some folks are just looking to maybe make easier publishing from a browser, and WebRTC is a really good technology for that. This might fall into your kind of personal video, personal broadcasting type use case. And there's tons of these, from social to lecture, where you want to be able to easily go live. And so that's a great use case for WebRTC. Another feature of WebRTC is it's real time. So it's not just easy to publish from a browser. It can also be low latency and real time. And so then that opens up a ton of different use cases when you start using WebRTC for delivery. This ranges from EMS communications to remote monitoring of security cameras, transactional video, maybe gaming, auction, those types of use cases. And then the more, most common use case of when its origination was, in terms of what it was built, is for that bi-directional chat use cases. So Wowza can support both the webinar or broadcast use case that is one-to-many, and then we can support, a few-to-few use case in terms of a chat scenario as well. Barry, I know you see a lot of use cases in your solution side. What would you add to my description?
Obviously, with folks being remote now more so than ever, the notion of this WebRTC based kind of sometimes interactive, sometimes just low latency videos has really picked up. People are trying to make easy ways for people to broadcast online. Obviously, being able to broadcast from a browser window with your MacBook or your iPad or what have you is a real win for a lot of people. And then we're starting to see people doing lots of events where they want to have some level of interactivity, where WebRTC provides a way for them to structure these workflows. They get complicated fast, to be sure, to be able to have a little bit of interaction with potentially a subset of the fans and the performer or something like that. So there's some pretty unique and pretty cool use cases on top of some of our larger customer use cases, like the emergency services, the E911 stuff people like Carbine are doing, which is a really cool use case.
Yeah, and it is cool to see that with WebRTC paired with Engine, or Cloud for that matter, it really opens up what type of use cases you can do with WebRTC. So moving on to browser compatibility. So browser compatibility isn't all cut and dry. There are some nuances between browsers that you'll want to keep in mind when building out your solution. I'm going to hand this one over to Frank to discuss.
All right, so I think this grid here kind of simplifies a lot of the key material that we want to go over, but just going through it really quickly, VP8 and H.264 are the two codecs that you're going to see most widely used and are most compatible across publishing and playback clients that are represented by the different browsers here. There are a couple things to unpack there when it comes to the browsers on mobile devices. In particular, Android devices using Firefox no longer support loading an H.264 plugin. So H.264 will not work everywhere. And to add a couple more important details, VP9, which is kind of the next generation codec that's commonly supported, is currently not supported in Safari. I believe yesterday, Safari just announced support for VP9. We don't quite know yet whether or not that means it's going to be supported for WebRTC, but that's something to look forward to. Anthony, do you have anything else to say? I think the only thing else that I kind of left out there was between H.264 and VP8. When you're focusing on WebRTC playback, VP8 is kind of dominating the market. It is the royalty-free codec, and it's probably used by, I think, what, 80% of traffic for WebRTC right now?
Yep. Yeah. For your all WebRTC workflows, it's definitely, I think, the dominant codec. And there's some interesting kind of stats that, around its dominance. I think the one thing that's probably relevant for this audience that might be doing a untraditional WebRTC workflow where you're only using WebRTC for, publishing or only using it for playback, that's when H.264 is going to be more prevalent. You got to be careful around profiles. You can only handle constrained profiles on the playback side. And you really limit your browsers based on which profile you're using. So that's another compatibility piece. And then the one, it's probably obvious on the slide because it says it everywhere, but it's easy to forget, Opus. If you're doing H.264 from, your RTMP encoder, you're probably used to AAC. So thinking about transcoding audio within that workflow. And we're going to touch on that a little bit later.
Well, so before we move on, I just want to stop and see if there's any questions about browser compatibility. If not, we can move on.
There are a few questions specifically about issues with different browsers. Like Michael Williams is asking, is there any way to work around Chrome enforcing 720p as a maximum?
So I think one answer to that is I'm not sure if they are having an issue with trying to go a higher resolution or lower resolution. But you should be able to constrain resolution in our hosted page examples. So you can play around with those. And in terms of going higher resolution, that's where you're going to run into trouble. If your camera is only 720, on your browser, you're only getting 720 out of that browser. So I would be mindful of that. Sometimes people think that they can do 1080 and they really don't have a source or browser compatibility for it. Thus, they're only getting 720 out.
Yeah, and we also noticed another thing, that when you are telling the browser to apply the strictness or the constraints around the resolution, when you move that resolution up to something higher, your likelihood or the behavior of that working with your camera seems to be a little bit different across devices. I think I've seen Chrome support maybe up to 4K on publishing. I know 1080p for sure works, if your camera does.
All right. And relating to those issues you talked about with mobile devices, did you have any specific pointers when using mobile browsers in mobile devices?
The most obvious gotcha that I'll call out, because I don't know if we explicitly really made it hit home. If you're on iOS, you got to use Safari browser. I think I get that every now and then. Someone just used to publishing with Chrome, so they're like, "Oh, Chrome's going to work over here." And on iOS, you have to use the Safari browser. So that's the first gotcha that I'd say as it relates to mobile browser support. What else would you all add?
I think that your likelihood of maybe not having support for something like a higher H.264 profile, maybe higher on like some older mobile devices, because they want to ensure that mobile devices are performing well, and that means that they need hardware support for like a higher H.264 profile for them to enable it. So sticking to a baseline profile, constrained baseline to be specific, will probably reduce your risks of interoperability problems.
That's a good point. I was reading earlier on just hardware decoding importance. And so, you start using VP9 because it's possible to use, but you could cause significant drain on the device you're publishing to if it doesn't use hardware.
Yeah, and
All
it's
right.
interesting when you look at the different devices, like Android seems like they may turn some of those on more, and there's a there's a lot more different devices that are created and that have different capabilities, where Apple owns not only its software and its hardware, so it's definitely gets complicated with Android.
Yeah, different Android devices have a widely different array of GPUs and things like that that they can do with different codecs. So it's kind of good to just stick to the baseline common things that you know would work across the board. You can go crazy and get super fancy and try to do browser detection and things like that, but it makes your workflow much more complicated.
All right, and one last question we had, which just disappeared. So it looks like our support is definitely answering them. We have many questions just about WebRTC in general, but I think we should get past this point before we start bringing those questions up.
Yeah, I think maybe for general ones, those would be good to answer at the end too. All right, configuring your WebRTC application. So I believe, Anthony, this is where you're going to be sharing.
Yeah, let's cover the slide first, and then I'll do a demo to get us really hands-on. So first, in terms of how you can configure WebRTC, we do now support WebRTC basic configuration within Wowza Streaming Engine Manager. So this makes it really easy. Any application you can quickly configure with a few buttons. You can hit our hosted pages to then test your workflow and get up and running in literally minutes. As it relates to then tuning your workflow, if you're really trying to either tune for latency or tune for publisher reliability, that's where you might need to get a little bit deeper in terms of configuring your XML application or configuring an XML transcoder template. And we're going to cover both of those today, but just get up and running, really easy from Wowza Streaming Engine Manager, quickly monitor stuff. As it relates to tuning, you're probably going to need to get into the XML, and we're going to jump into those items.
All right, stop sharing.
Great. I'm going to get us rolling on a demo now. The first thing I'm going to do is turn off my camera so I can start really showing you some WebRTC work and share my screen. So you should be sharing my screen now. This is our hosted pages. I'm going to start actually over on the Wowza Streaming Engine Manager side of the house. So this is Wowza Streaming Engine Manager. I'm just running this all locally for the webinar purposes today. And when you get started with WebRTC, there's one thing that is critically important to do. And if you're already streaming, you probably have it set up, but you do need to go and set up your Streamlock certificate, or just bring your own SSL certificate for secure streaming. So WebRTC uses that. Any sort of HTTPS workflow that you might need will also be using it. You can do all that over here on your virtual host, and you can see I've set up WebRTC on my Streamlock port. You can share this with HLS if you're concerned on that. So everything's just going over 443. And we have a great video of this that Justin actually made in terms of getting started. It's about a 4-minute long video, shows you end to end from Streamlock to the local configuration on your machine. So now let's go ahead, and I have it set up. You can see it says true over here. Let's actually run this end to end ourselves. So I'm going to create a new application and call it webinar. And so now I'm in my webinar application. And there's a few selections here on, what kind of playback types I want. And one thing I would add, if you're using, a non-WebRTC source, is you do want to run your application in low latency mode. This will, if you're under the use case of using an RTMP encoder, going out with WebRTC, this ensures that, all the buffer handling for that workflow is going to be as small as possible, so you can get that workflow to be sub-second from your RTMP encoder out WebRTC. Another interesting one that was added in 485 for WebRTC in particular was just a connection limit on your application. Various reasons for potentially wanting to have that. I'm going to go ahead and save everything. And if I jump over to the left nav here, you can see that we have a new item. So WebRTC is now a configurable option. We do default it so that it's not on, but you can just click edit and go ahead and add these. And so you can see I can add in publish, play, or the query parameters for you to be using that API method. You can set up your ICE candidate. The ICE candidate should be using your your IP address of your server. A quick reminder of how you might even see that. Here's my server IP address, so I can just go ahead and grab this one. I'm going to come back over here and go ahead and edit this to be where I am right now. So this is my internal network again. And then you can choose your codec selection. So we have your priority codecs. You could add VP9 to this priority list and use the toggle buttons, but I'm going to just be happy with these settings. So that is all set up. I'm going to restart my application. And now if I were to actually stream to that application, I'll be able to see it. So I'm using this app called Webinar. So I'm going to go in here and change it to say Webinar. Here is my signaling URL. So this is using my Streamlock cert. My application name is right here. And then I'm giving it a stream name of just Webinar Stream. And I'm going to go ahead and publish in. So if I come over to Wowza Streaming Engine, I should see incoming streams. And so there it is, my incoming stream for WebRTC that I published in. And one thing that I'll also show you, which is a great way to just keep track of what's going on and troubleshoot, is you can use the Chrome internals. And I've been doing a bunch of streams. So I'll try to find the right one. I think it's probably my published one over here. And I can go ahead and see my bitrate coming out of the browser. So Chrome internals, again, you just go to Chrome, :/WebRTC internals. This gives you a lot of information to help you debug and figure out what is going on. And you can easily see, how your bit rates are doing. You can see if there's, any sort of issues with your connection in terms of dropped frames, etc. And so you can do this on the publish and the playback side. And I'm going to go ahead and play that stream just to get this part of the demo complete. So I'm going to change this to be webinar. Go ahead and click play. And there I am. And so if we wanted to kind of pull this to the side potentially, I'll give you a side-by-side look. And so you can kind of see the, the latency is, certainly sub-second is probably around around the 400 or 500 millisecond for this little demo here. Maybe a little quicker because I'm all local. So that is the first thing I wanted to demo, and I'll take a pause now. But that is, again, just like a quick get started WebRTC setup. And I'm going to demo a few more advanced things next. But any questions right now, Justin, to pause on before we keep moving?
Sure. One question being, what is the scale that's achievable then with WebRTC?
Sure, we're going to cover scale in a couple slides. We have some content to review on that, but it depends how you're trying to scale. If you're trying to do everything on a single server out, you're talking hundreds. If you obviously repackage, you could do more. If you set up a load balance origin edge, you could potentially scale even larger than that. But I'll show some more, and we have some content to cover that in a bit.
Okay. I'm not sure if we're going to be covering this later, so I'll ask these questions. But many people are asking about delivering the WebRTC content using Dash or HLS, or being able to display that WebRTC ingest on an HTML5 player.
Yes, so we can go ahead and demo that, but the key, and I'll do that in my next demo, the key to do that is you're going to have to transcode your audio from Opus to AAC. So that's the most critical item. The other things I would call out that can become interesting roadblocks potentially for some people is if your source streams with WebRTC have really low frame rates because you're only showing a slide, you might see some different performance as it relates to processing through the transcoder, especially with latency. And there is some features that we're going to work on in the second half of the year to really help you manage WebRTCs to HTTP protocols to correct for those oddities of WebRTC in terms of how it chooses to optimize bandwidth with reduced frame rates.
Okay. And before we get to that, there's a number of people who obviously they look at WebRTC as a solution for teleconferencing. So they're asking, do you support multiple people publishing? And how do you add more people to a WebRTC session?
Yes, so we actually are going to get we had a demo up previously that we're making changes to, and we'll probably get that up sometime in July. But our implementation can use something that's an app instance, so you could actually define a group within your application, and then you can use that query URL API to then identify all the participants and then pull those into the WebRTC session. So there is, support for this in terms of Wowza streaming engine now. The implementation on the browser side, we're going to get some better demos to showcase how to do that. To make that a little easier for you.
Okay, and one last question here. Some people wanted to know, what player does WebRTC use? In other words, how are we seeing the playback of WebRTC egress?
It's all implemented in the browser, and that's one of the nice things about the WebRTC standard from the browser side, is that it allows for a robust set of APIs to set up for publishing and playback and monitoring of your streams. And that's all implemented in each of the different browsers that we went over a little bit earlier. Similar to like an HTML5 browser.
Exactly. There's no plugins required. It's all done via JavaScript and things like that. So there's no external things like a third-party player or any sort of plugin or extension required.
All right.
All right. Well, let's jump back into the demo. Thanks, Justin. So I'll cover two things in slides, and then we can showcase how to do this in Wowza streaming engine. Two ways to tune your workflow. I think these are the most common things we hear about from folks, is tuning for publisher reliability. You might have people that have network issues because they're at home or out and about. So how do you tune for that reliability? What we've implemented is a jitter buffer and NAC implementation to allow you to have those retransmissions and really do better in terms of your resiliency to network conditions. This is not on by default. We have the properties in our documentation, and there's even some debug and logging for how those properties work, which can help you tune the property itself. So the jitter buffer by default is a 500 millisecond jitter buffer. You can actually work within engine and kind of really find the optimal one for your network and conditions. This should help immensely if you have users that are publishing in areas of packet loss. We really recommend for this use case, you should use UDP. A big issue with TCP when it comes to poor networks is that it just makes the problem worse. So TCP has some, network resiliency built into the protocol, but when you have bad networks with packet loss, it causes everything to fall apart. And so UDP is the way to go with the jitter buffer and NAC implementation. It's going to allow you to really push through some pretty significant packet loss scenarios. And the other thing that we would recommend too is just letting the browser choose the bitrate. So if you looked in the demo, you can see how I chose an audio bitrate for the stream, but I didn't choose a video bitrate. And if you were paying attention to that Chrome internals, you'd see that the bitrate was kind of slowly increasing in the first 10 seconds of the broadcast until it firmly established itself. For something like a 720 video, you'd probably see a Chrome browser on good network rise all the way up to around 2 megabits per second before it kind of settles in. If you were in a bad network, it might stay low and hover around 500 kilobits per second, maybe even drop the resolution. So that's one way to tune for publisher reliability. The second way to tune is tuning for latency. When you're doing WebRTC to WebRTC, this is probably less of a question. When you are doing your workflows where you're having, let's say, an RTMP source, you need to actually transcode WebRTC to a non-WebRTC protocol. That's when you're likely to hit more areas you need to tune. There's a few spots. One is tuning at the application level. I showed you how you could enter into the latency mode a minute ago. And then the other thing is tuning your transcoder. And so this is adjusting the buffer size that might be used on the transcoding workflow. So let's jump in and showcase those. I'm going to come over to, I'm going to just show one thing in our documentation first. So this is our article on setting up WebRTC in Wowza streaming engine. And you can see here are some of the XML configuration items that you can change, and down in the RTP section, that is where you can set up jitter buffer and NAC. So I was showing a screenshot of how you could configure those properties, but these two at the bottom, if you just wanted to run with our defaults, would be the ones that you would be wanting to change. Frank, I know you've worked a lot in this area. What would you add to this?
I would just make sure that you're following this advice to begin with. I think it's going to lead to the most success in most workflows. I certainly agree with Anthony's comments about the choice of UDP over TCP. When looking at a couple of these other things, I think if you were really wanting to optimize for low latency, using the jitter buffer debug and tuning your jitter buffer delay could allow for you to shave off some latency because of how negative acknowledgement has a requirement for a certain amount of size to that jitter buffer. And what I mean by that is when Wowza streaming engine notices that there's packet loss, we have to request that to be retransmitted, and that's going to add that round trip time that you see there that's configurable. But a requirement for the jitter buffer to be sized greater than that round trip time for us to properly retrieve the lost packet and play it into the system.
Awesome. Thanks, Frank. So let's jump into a quick demo of this. So I'm going to jump into an application called Live over here, and I'm going to demo a RTMP workflow to WebRTC. And so to do this right, I'm going to have to get a template to transcode my audio from AAC to Opus. And so I'm using the audio only transcoding template. Excuse me. And I set my transcoder to enabled, and then I tuned that transcoder template. So if I jump over into the templates, I have it open over here. What I did is I actually killed the buffer. So if you look at the sort buffer, I set it to false. And you can see previously by default, whenever you're encoding or transcoding, they like buffers, these encoders, to make the video better. But you can kill that buffer to make it all go faster. And so if you were to tune this, essentially the transcoder is only holding on to about 5 frames before it's going out. So I'm going to go ahead and get the workflow started. I've set up just OBS in a computer running next to me. And you could do, OBS has a really good low latency mode. So make sure you just choose advanced X264 and choose that low latency mode. The Clearcaster, Wowza Clearcaster hardware encoder similarly has a, 0 latency mode in it. People don't realize how much latency an encoder can add, but it can be about a full second. So some encoders can't be tuned. If your encoder can be tuned, then make sure you tune it to have that 0 latency capability. And so here are my 2 streams coming in. So this is in my live application and my OBS stream. And so I'm going to go over to my player. And I guess I might have closed it, so I'll have to. So I'm going to change my application name to live because that's the one I'm using now. And my stream is called my OBS stream. And so I'm going to play, first I'm going to play the one that doesn't have audio in it. And so this is an interesting workflow for some folks. So here's my source stream that isn't transcoded. And I can still play that back in WebRTC. And if I turn my video on, you should be able to see the side-by-side latency of myself and then the camera here. And I think the Zoom screen share is probably pretty fast, but you can see that's definitely below a second in terms of the latency. But because I didn't change the audio, I'm not getting any audio on this stream. So if I were to actually go through the transcoder and click play on this, Now, hey, I have a stream with audio. And if you look at the latency, you can see it still is super fast. And that's because we have tuned that transcoder to not have that really big buffer. So you can get a very great real-time workflow and be using RTMP or another source protocol, SRT, RTSP from an IP camera, let's say, and be getting out the door with WebRTC really, really fast. The other trick to this, which I didn't really cover, was with your encoder, it's really important you choose a profile that's going to be supported on your playback browsers. The most common denominator, you're going to go with baseline here. Some browsers can support a constrained high, so meaning like no B frames, and using that constrained high profile can really get you a better image quality and look really good. And so real-time streaming, you can still get a really good image quality out the door and be using that kind of untraditional way for WebRTC of a non-WebRTC source. I think one other thing that I've heard mentioned here was how to go out HLS. And that's really easy. All you have to do is essentially do the opposite of what my transcoding profile is doing right now. So instead of taking AAC and turning it into Opus, you take the Opus from your WebRTC source and you turn it into AAC. And that is actually one of the default transcoding templates in Wowza Streaming Engine. So if you're concerned about latency, then you just tune that buffer size, but otherwise you can be going WebRTC to HLS with that default transcoding template of that audio only. The other concern that I hear sometimes from folks about this is, oh, it's going to be a lot of compute. If you don't transcode that video, then the computational, impact on the server for only doing an audio transcode is way less. So that is, a big benefit for your workflow, and again allows you to kind of do that, untraditional, let's say, WebRTC workflows, and that's where the media server can really shine. So allowing you to have that real-time streaming a few different ways.
And Anthony, I wanted to reiterate that in those examples you showed, either way, you did not, it's not at all required or necessary to transcode the video. Only the audio to go from Opus to AAC or AAC to Opus is important.
Anthony,
yep, exactly.
Do you think you could share that screen again and just show us the template itself, just so people could see it?
Sure. And I guess the one other thing I would maybe call out for folks who try to implement this at scale, again, the source encoder, if you're going from RTMP with H.264 to
I think you're sharing the wrong application. Oh, okay.
I'm in Notepad, I think.
Okay.
So this is, so this is my audio only transcode.
Got it.
So you can get away with audio only transcode if you ensure your encoder that's using H.264 is tuned with the correct profile of H.264, as well as doing a constrained profile. If you are a service provider and you, let's say, can't trust your end users to have, the encoder always set up correctly, then you might need to actually transcode the video just to always be safe, right? In which case, you could go that path, but getting your users to tune it, their encoder correctly, helping them out there, going to go a long way. If you look at this profile, again, it's, this is actually the default audio only profile. I changed Opus, and one more thing, I guess I went kind of fast, so I'm not sure if I spelled this out, but you need your sample rate to be 48,000, excuse me. So if your encoder is doing 44,000, you can use this in the profile to change that sample rate for your audio.
Somebody was actually asking why it needed to be 48,000.
So that's the WebRTC spec for Opus. So you got some requirements to hit. It's got to be Opus, got to be 48,000. Frank, do you know more for maybe why, or?
I think that's kind of an interesting thing. I don't know if I can have too many answers for that, but I do know that, like, in general, audio is to be prioritized in video conferencing. So by keeping the audio bitrate static and allowing for a couple other improvements that they packed into Opus, like in-band forward error correction, I think by keeping that static, allowing for some recovery, that allows for audio to be prioritized, because if you're able to bring that up, scale that up and down like we do with congestion control for video, it probably would be harder to do that.
Thanks. Generally speaking, though, then you'd recommend that incoming audio always be at 48 kilohertz if you're expecting to be converting it for WebRTC.
Yeah, yes. I mean, it saves you some time in the template. If you have to be transcoding anyways, it's really not that big of a deal probably, because you're already going from AAC to Opus. Just to summarize, really fast, this workflow, the key takeaways is definitely tune your encoder and transcoder for, latency. So your buffers, etc. Tune that application and Wowza streaming engine. So we covered that at the beginning. And then the other thing I'd call out is like not all video use cases need audio. And it's really interesting. Some of the folks that I've seen, take their IP cameras and other sources and just have that video feed. I've seen broadcasters using this to just get really fast real-time visibility into multi-viewers. I've seen security campers use this
big for security
video only workflow because those IP cameras on top of buildings, the audio doesn't really matter anyways.
So we see that a lot, Anthony, in the in the security and surveillance workflows. Very, very little audio in those in general, so you can just pump them through.
Great, and I think that covers kind of some of the engine demos. Anne, do you want to take over?
Yeah, we're going to move on to scaling WebRTC. And we're going to pop open, okay, I think you guys can see my screen. We're going to pop open a poll first. Might take a minute. There we go. So yeah, if you could answer, how do you currently or intend to scale WebRTC to a large audience? We have 3 different options: repackage to a higher latency protocol like HLS and stream through CDN, scale on a single server to hundreds of viewers, and scale WebRTC with an origin edge. And of course, we have others. So we'll take a minute or so for you guys to answer. Maybe less than a minute. I'll give another 10 seconds. All right, I'm going to close it out and then move on to scaling WebRTC. Oh, here we have the poll results. So it looks like most of you guys scale on single server to hundreds of viewers. So that's really interesting. That's one of the topics we're going to talk about right now, followed up by repackaging to a higher latency protocol like HLS. This is also interesting, I think, especially once low latency HLS is completely out with Apple. I think that's going to make a really big difference for you guys that are transmuxing to HLS, and hopefully we'll get a lower latency there. Okay, so choosing how to scale your WebRTC workflow. Like I mentioned before at the beginning of the webinar, one of WebRTC's limitations is its ability to scale well. But when paired with Wowza, you can scale your streams effectively. So let's talk a bit about how we can do that. I'll turn it over to the panelists.
Sure, kicking off, one thing that's probably most common here is going through a CDN using an HTTP protocol like HLS. We do have a implementation of low latency HLS, which is getting a lot of buzz, and Apple, just essentially hinted that it's going to be available in iOS 14, which is second half of this year, and we're going to be ready to support that through a CDN. We've done, some end-to-end tests with that. I mean, Barry, do you want to speak to maybe some of the performance you've seen on low latency HLS end-to-end?
Yes, yeah. So we have a few customers and partners, I'm going to say, experimenting with this. We're using folks like TheoPlayer and folks like Fastly to help us test these end-to-end workflows, and we have customers doing prototypes. Certainly, once you add the CDN component in, there's a level of complexity there, and it does add some latency as the packets propagate through the CDN network. I've seen latencies as low as 2 seconds and even sub 2 seconds in a local environment, with streaming directly from streaming engine, even as a cloud server. I expect to see latencies, somewhere in that sub 5 second range for sure. Early testing with some of the CDNs, we're seeing around 3. I think that can probably be tuned down. So, once you get your stream into the CDN network, because they're typically high performance, very optimized networks, I think you're going to see some pretty impressive latencies and the ability to scale to millions at a very much more cost effective standpoint than you might be able to otherwise. And a lot of these will be hybrid workflows as well, where you may have a subgroup of people viewing a super low latency stream, and then the passive audience viewing HLS. And you imagine people who are watching an auto auction, for example. There's a lot of people who watch auto auctions just to watch the auto auctions. Not all those people are bidding. So the couple hundred people that are bidding could easily be on the WebRTC stream. The larger scale audience could be on something like HLS.
Interesting. Do we have any questions about scaling WebRTC?
We do have questions related to low latency HLS. Some people wanted to know how we feel about how that compares with WebRTC.
It's never going to be as low latency as WebRTC. They're very different protocols and they work very differently. So, if you need sub-second latency, for now, your choice is likely going to need to be WebRTC.
Okay. And there are definitely people who are interested in knowing if there is a CDN beta for low latency HLS that they could participate in.
There likely will be. We have not announced that yet in terms of having that workflow through partners. But we plan to have support, from Wowza Streaming Cloud. So it's super easy for you to get this low latency stream through a managed service. And we plan to support it through Wowza Streaming Engine as well.
Yeah, and it would, a lot of people were basically waiting for WWDC this week to kind of pull the trigger on some work to make sure Apple didn't pull a fast one to make any changes at the last minute. It appears everything is remaining relatively stable, and that HLS will be, low latency HLS will be part of iOS 14. You're going to start to see it pop up in the betas. So I think it's going to unleash some work that people were maybe hesitating to start. And I think you'll see some CDNs begin to support this, over the next 6 months. And as Anthony said, there's certainly to be a beta, I would think, in that time frame. And then, Wowza will be ready to go to production with these as soon as it's ready.
Awesome. And just to remind people, the questions we're answering right now are coming into the Q&A window. I see some people trying to raise their hands. If you could please type them into the Q&A window, we'll definitely discuss them. Thank you.
All right, anything else you guys want to add on scaling WebRTC?
Now let's jump to the next slide because that covers some of the topics. So here's a load test. This is there's a few different ways to use, load test WebRTC. There's some open source, GitHub examples for how you could do this. We actually used a commercial tool for this. TestRTC has been, a tool that you could programmatically tap into as well as run some manual tests. And this is using their tool. So on the left, you can see the test itself. So all those green bars are 100 different clients joining the session, and they're joining at a rate of 4 calls per second. So trying to simulate, people joining a webinar like this. And so that's what all the green bars are. You can see then the bitrate performance here of it kind of rising. As I mentioned, it does during that initial part where it kind of establishes what bitrate it should be sending, and then it kind of progresses throughout the rest of the webinar. The two things with scale that I think are really important to come out. So you can see the right side of the performance. So 100 viewers, we were using a bit over 20% of the CPU. This is with a C5 extra large on AWS. There's two things in terms of scale and load that is going to impact your server. One is that rate of joins. So the number of calls per session that you're seeking to connect to, calls per second, excuse me. And so the higher that is, the more load it is for those initial connections. And then it's the ongoing persistence of those connections in terms of the sustained viewers. So this type of server could easily handle, hundreds of viewers, but in terms of getting all those viewers to join within the same 5-second window, that's where you would, or 10-second window, that's where you'd really create a bottleneck in terms of your sizing. We are hoping to publish some more benchmark reports in Q3 on load for WebRTC across both of those parameters. So that should really help you spec out your infrastructure. For now, what I typically see is folks getting a decent sized machine, able to sustain, hundreds of connections. We've seen, a couple users that have like just the beefiest, servers out there getting over 1,000 viewers. But I think your common use case is probably more in the hundreds, which we kind of see from our customers so far.
Awesome. Do we have any questions related to that?
We don't have any questions specific to, these load test results. We definitely have multiple questions coming in about WebRTC though.
Okay, let's move on to this next one, publishing and viewer access control. So Frank, I'm actually gonna let you take this one and talk through it.
All right, so I think the first thing to start with publishing and viewer access control is to kind of talk about the 3 actions that you can do when speaking to a WebRTC server. In particular, most of these are done through our JavaScript examples that you can see on our GitHub page. And those 3 things that you can do is you can basically publish streams, playback streams, and then ask what streams are available. So digesting that, we have a great article here that's, I don't know if we could share that in the chat or somewhere else, but we see a snippet of how we can further add access control methods to those 3 separate commands, because it can be done so separately. The way that we allow for users to do authentication is going to be over the WebSocket connection that is established between a WebRTC publisher or playback client and the Wowza streaming engine server. And the way to actually do authentication is by attaching query parameters through the URL that you have access to through a module-based approach, or through JSON, which you can send in addition to your messages that ask engine to play, publish, or query for the available streams. The next couple of things we have here, we kind of touched on briefly. That's going to be restricting the number of concurrent connections. That's something we added in the last release. And then we have SDP exchange customizations. We have some callbacks for this. I don't know if these are currently publicly documented, but they could allow for this to be done.
Awesome.
You got anything else, Stan? Add, Anthony, you think?
No, I think that's the key is, the article articulates it pretty well for some examples, but it is possible to control that, who's viewing, who's publishing, which I think is, always when you're building out a service, the primary concern.
Yeah,
I was gonna say, if anybody has specific needs or needs help with this, obviously our professional services team would be happy to engage with you and walk you through this and or just create this forward for you for your specifications. You have a lot of options, including mimicking like what you do with the token auth for a different kind of like an HLS stream. So just give us a call and we'll help you through it. We're working with some customers now that are having these exact needs, and we'll get it done.
Another important thing I'd like to call out is this WebSocket connection that's constructed between the clients and the streaming engine is run over a secure WebSocket connection. So that is TLS encrypted. So your messages going back and forth between engine are not in plain text over the internet. And the query and the path elements, which are parts of your URL, which you could also embed data in, to do some form of authorization or access control are also encrypted with TLS encryption.
That's a good point, Frank. It's worth knowing that the video data is as well, right? So the WebRTC protocol is secure from end to end.
All right, Justin, do we have any questions about this one? If not, I'm going to move on.
I think we can move on.
All right, so last up is the WebRTC roadmap. So Anthony, I think this is a good one for you to talk about what we've delivered so far and what we will be delivering for the second half of the year.
Great. So yeah, in the first half of the year, just a ton of improvements around reliability, expansion of use cases, increased documentation, new GitHub repos, and demos for you to take advantage of. If you aren't on 485 yet, get on 485. This will have, the best of the best stuff in terms of you implementing this workflow successfully. So we just really encourage that and really happy to provide it to you. In the second half of the year, a lot of fun things, I think, that are going to help you get better quality, also even expand your use cases. So improvements on delivery quality. So getting some of those resiliency mechanisms that we implemented on the publisher side over to the playback side is going to be a top priority. Getting more examples for you around meetings so you can get those kind of 3-4 person chat scenarios built easier. To go along with that, we're going to work on some compositing elements. The first take on this is actually going to be using some of the browser for compositing and using the browser canvas to allow you to seamlessly, put a couple sources together and send that to Wowza cleanly. What's really nice about this workflow is that it will reduce any sort of transcoder needs that you might have on the server side. And just simple things like allowing a toggling back and forth between screen sharing could be done successfully this way. So we're going to get some of those demos up and examples out to you probably in the first in Q3 timeframe in terms of the second half of the year. And then the last one that I'd call out is scale. We talked about this a couple slides ago, but implementations with the latency HLS, further scaling for WebRTC, and further documentation and giving you benchmarks so that you can just set up your infrastructure successfully, or, with greater success, is going to be a priority for us as well.
I'm going to move on to the next slide. And also we have about 5 minutes left. So I think we could open up, Justin, to any of the more general questions or questions you would like our engineers to ask.
Yep, absolutely. One question, which I think you just answered, Anthony, was about supporting multiple presenters publishing their videos in WebRTC. It sounds like you're going to have some examples on GitHub in the next quarter.
Yep. So we're continuing to build up that GitHub repo. I think we'll be getting screen share added soon. We'll be getting the meeting example added shortly after that.
Awesome. Another question we had is, can the WebRTC protocol handle high resolution streams like 8K or even 360-degree videos?
So there's all sorts of crazy stuff going on with some folks and what Chrome is pushing. I think I was even reading some AV1 implementations. So what's possible? I've heard of 4K. I don't think I've heard of 8K. What is realistic for common use cases? Those would be very fringe use cases that if you had specific browsers, you might be able to really eke out amazing performance. What else did you add, Frank?
You're going to get different performance on playback versus encode too, right? The browser's going to struggle encoding 8K in Chrome on a desktop, most likely. You may be able to play it back, however. So, if use a standard encoder, do a 360 4K stream, send it out, to a specific browser, it may work. The publishing side's going to be a little more of a challenge, I would think.
Yeah, I mean, it's a lot of bandwidth. 4K, you're looking at 4K stream, you're looking at maybe 20 megabits a second. And I think it comes back to the, practical, we're going to come back to how practical this is. It is certainly doable. You're constrained by what the browser allows you to do. And that specifically is going to be the get user media constraints that's allowed by the browser and also by your input device that the browser is using. And that can be your camera on a laptop, or that can be whatever device that you're plugging in through a USB. So there's a lot of combinations to think about with what devices you could plug into WebRTC.
All right. We got about 3 questions here left, and I know we got about 2 minutes, so let's see if we can answer them quickly. One of them is, could you explain about DRM support with WebRTC?
So I don't know how much I think this makes sense in this conversation. I think to go back to the basics of WebRTC, I would say that if you're looking at how things are encrypted, they're firstly encrypted with DTLS, and that's going to be similar to a TLS network layer encryption. And the actual media is also encrypted with SRTP, which sits at a higher level in the application protocol stack that is just encrypting, the content of the media or the metadata you're sending.
Okay. This one's very specific. How many publishing WebRTC streams can Wowza handle at once on AWS using a C5.X large box?
So that was close to my example, right? Except for it's publishers instead of viewers. I think in terms of sessions, I think they kind of are weighted equally, publishers and viewers. What could become a bottleneck too is that calls per second. So the number of session connections per second would be a bottleneck. So I would say hundreds on that server. We're likely to get some official specs out in Q3, and that would, probably be one of the servers we officially benchmark against.
All right. And the last question I have here is there a timeline for data channels?
There's not a timeline for data channels. It's stuff we're talking to folks about. So if you wanted to shoot me a note, Anthony@wowza.com, and tell me how you're implementing or desiring to implement data channels, certainly would be interested in hearing about it. It's not a Q3 item in terms of this next quarter, but we're looking at how we would potentially implement it and for what use cases it would serve well.
All right. Thank you, Barry, Anthony, Frank.
All right, so that is it. Thank you for joining today. Thank you for our panelists. And if you haven't done it already, please download 4.8.5. If you're not a customer, you can pull the developer license trial and start testing WebRTC with that too. The URL is on the page we're looking at now. All right.